One of the main steps to perform on a steady optical thermal analysis or continuous optical thermal analysis is the UOT or COT initializations. Is the step to assign the number of layers of the tooling and the tape and also the boundary conditions among them. You could also find more informations in the help of the software. You will see in the UOT and COT initializations and more informations about how to add the informations and what are the each object to assign and set the boundary conditions. Here we will have a look at the brief performing the boundary conditions for this UOT analysis, and then we will have a look at the COT analysis. So there are a little bit differences between the initializations for boundary conditions between two modems, and then we will have a look first at the UOT analysis. Here our example is about we have different toolings, like 3 tooling with different properties, and between each of them would be the boundary condition and thermal resistance, and there would be a one tape on it. To perform this, we need to go to UOT-COT initializations. We add the number of the tooling, which is here is 3, and the number of tape, which is here 1. You could change this number later at this window. So this is the window. At the first one, first edit box is a STL file that you would like to use. And then there would be for tooling 1, tooling 2, and tooling 3, the mesh file. You could set the solver, the explicit or implicit ones. Explicit is a little bit faster, but implicit is always more accurate. And also the number of tapes. For a UOT, the number of tapes is always 1. You could add the layer repeat here, which here is 5. You could change it, for example, to 2, or anything's just repeating on the same path. This is UOTs for the simpler geometry and simpler conditions. But for complex condition, you need to do the COT, which this layer repeat does not taken into account, and you should add different extra tapes. Here we will have a look at the UOT only. So I'm going to show you what is here we have. You could change the number of a tooling and tapes here if you want to change it during the setup. You could also read the power from the layup, so you could have a different power per layup. You could save the initializations, and you could also load the layup, which is only for COT, this one. You could load the setting that you inserted here, and you could also resume the analysis from previous analysis. We don't go too complex here. We just select the simple plate. So for STL file, click on Butters cat file and select the STL file, the simple plate. Here we have these 2 buttons for the axial and planar is to centering the STL file and mesh toward the center based on the plane ones. So if you have plane shapes, that you should select the planar shapes, and if you have like a cylinder or tubes, you could select the axial ones. So it's just a centering of the geometry, and all of the mesh file and STL will be centered at that locations. This is also the centering plane. Then you need to add the mesh files. Click on Butters file and select the mesh file. So for the tooling 2 and 3, I use the same mesh file. It means that the software automatically make it the whole mesh on top of each other. So the tooling 3 would be on top of tooling 2, and tooling 2 will be on top of tooling 1. Here we could add the thickness here, but the software also detect the thickness automatically in the COT version. I selected all and implicit. You could also change it to explicit. For the mesh of the tape, you could select the mesh that you created through the UOT kinematic on the CAD. So I go here and select the file, select the mesh file that was generated during the UOT on the CAD. Select one, for example, one path, like that. So this is the first one in here is a thickness, and the second one is a number of discretizations along the thickness direction. This is the thickness directions for the local analysis. So we have a local irradiation zone and consolidation zone, which this one is a number of discretizations. The local models of irradiation and consolidation are only available for the UOT analysis. In COT, all of the calculation will be done in the global model. So this value is just for the local irradiations and consolidations. Here we have heat transfer coefficient. The first value is the irradiation zone or the global zone, and the second one is the consolidation part. The last value is for the intimate factor, which was used in the previous version. Now this is going to be obsolete, so that is not in use anymore. You could increase the value of the heat transfer coefficient. So higher heat transfer coefficients means that the heat transfer between the layers would be higher. You could select, you could find the typical values in the literature between the materials. You could assign the material here. You could, for example, I assign it as a steel material. The second tooling or third tooling, I put it as a peak material, like that, and also the peak material. You could load a different material via the load materials. So when you click on it and select a specific material, this option will be, this material would be updated. Here, if you have, if your material consists of 2 or more materials, you can select a +1 material, and then, for example, you could assign a different material for different sets. You should assign a set on the mesh if you would like to use these options. So if you have if you set different nodes and different elements to have a different material, you could set it as the mat1 or mat2 or mat10, for example, and you could assign a different material for each set of the elements. So we don't make it complex here. The next one is about the assignment and between the CAD file and the mesh. You don't need to change this value, but if you have a higher curvature, you could change this value from 0 toward the 1. So, for example, if you have a curvature, you can add it to 1, for example, or 0.9, close to that one. So it's to detect the upper layer and bottom layer of the surface to assign and assemble the tooling 1, tooling 2, or tooling 3. This is the initial value temperature here. And if you set this thickness as 1, the material, the temperature at that specific material will be fixed. This would be the layer repeat. So if you put it at a 6, for example, there would be 6 layers after tape 1 will be placed on top of this 3 tooling. So these 3 tooling are there, and there would be 6 repetition of the tape 1 on top of each other. This is the material estimation parameter at this temperature. And this is the roller press, so the roller convection coefficient will be multiplied by this value. This convection coefficient of the roller would be found here, so this 60 multiplied by this value, which is 100. This is the delay between the layers, so you put 1 layer and there will be 20-second delay. And if you change it, for example, to 1 to 10, the delay would be like 10 seconds. And this is the delta time that the solver will be used. So lower delta time will guarantee the convergence, but it takes the higher steps to reach that convergence. So it is usually recommended that you don't change the default value, but if you don't get convergence, decrease it. So the would be the smaller time steps to reach the convergence. This reset value, if you click on it, all of the information will be gone, would be like deleted, these edit boxes. So if you would like to new analysis, you could click on reset, and all of the edit boxes will be resetted and cleared. When you are done, you could click on OK. To save this UOT initialization, set the name, set it as analysis 1, test, and when it's done, the information regarding the analysis will be saved. The data will be saved here in there. Here on the application supplementary files here, and UOT initializations. So this is the setting that you just generated.